Trying to see. We can hear sounds. Can we hear any sounds? That is a question. That is the question. Rad. Very excellent. Good. Oh no. Oh no. Oh yeah, no, it's ah. Um, let's see. Ishkoi. Hmm. I like that sound. That's good. Yes. Da 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 da. I think I know what I did. Oop. Excellent. Okay. Alright. Oh, I'm stuck in the ground. Wow. What the fuck? Okay, here we go. Good. Alright. So, let's see what we can do. So the first thing that we're gonna do is we're gonna make a cube. Put a little cube in there. I'm gonna be using 2 or 3 plugins primarily. Firstly, GMod, Essential, and also this see this outline that appears on everything. This is called I think, what is it? Easy Precision. I just put it on here. Hold on. Find it. Add-ons. Smart Snap. My bad. Okay, so it's Smart Snap. So like it creates a grid on objects, and if you press E, it focuses on the point, and you can walk around, and that just makes it easier to get more accurate models. Anyway. So, what do we got? We got a cube in 3-dimensional space. And we want it to not fall. How do we do that? We negate the acceleration of gravity in the game world. And we use thrusters in GMod to do that. So let's put a thruster on the bottom. Where the hell? Find him. Where's thruster? There we go. Okay. So in GMod, thrusters do some stuff. They have a direction. Oh, damn it. That's okay. They got a direction, and they apply a force in the opposite direction. So like this thruster is pointing down from the cube, and it applies a force to the cube and all attached objects. But I think all attached objects through the cube in the opposite direction. So the thrust will come out downward, and the cube will push up. In fact, to demonstrate this, first I'm going to use not wire thrusters, so that we have an idea of how this works. And these are activated by the numpad instead of a wire system. And I'll explain the wiring as we go along. So let's put a simple thruster down. It has a force of 1500 units. I don't know. Oh, there's one other thing that I should have, which is mass tool. Oh wait, yeah, it should be able to tell me. Okay, so we got a weight of 8 on the cube. So force is mass times acceleration, so we got like a weight or a mass really of 8 times the downward acceleration, which should be, I'm not sure what it is in GMod. I think we'll have to figure that out by trial and error, but it should be, it's either going to be like 9.81 or it's going to be 10 units per second squared. And something actually that I didn't think about this, GMod, I think the source engine uses imperial units for some reason. I don't, because Valve is Americans, and that's 32 feet per second squared instead of 10 meters per second squared. So I'm pretty sure it's going to be 32. So 32 times 8 is what's 4 times 32 is 128 times 2 is 256. So we're going to have a force of 256 units upward. So that force is going to be a lot. What I expect to see is that since 1500 is markedly greater than 256, we'll see the cube go flying upward when I activate the thruster with the button 8. And it does. It goes really fast. And it comes down in the same orientation with a little bit of randomness. In Gmod, the way that objects attach to each other is not perfect. As in, for any motion, attached objects have a bit of lag behind them. There's some like flexibility in joints. So as a result of that, things kind of wiggle around a little bit, and between frames you get some like, not quite Brownian motion, but it's like, you know, it's weird. It's weird shit. Oh, you do that. Okay, so I'm going to take that force and dial it down to 256 and see what happens. And I know that it's not going to work exactly as expected, or I don't think it will, but I'll explain why when we try it. So, it was, what was it, 8? Interesting. Nothing seems to be happening. Let's see what happens if I turn it on the side. We can test to make sure that the thruster is working. Oh, well, there it goes. Yep, okay. So there's another thing going on here, which is that, let's just do this right side up front. Alright, so it doesn't equal gravity. This is not equaling gravity. This is, you know, well higher than the force of gravity in the game world. So what's happening is that our thing is going up pretty fast. And this is due to the fact that not only does the cube have mass, but the thruster itself has mass. So the heavier the thruster, the more force it exerts, except this is the thing. We got a mass of 1, so 1 times 256 should be 256, which is the same thing as, what, 8 times 32? So maybe there's something else going on here. Maybe maybe it is actually in metric units. So let's change the thruster's power down to, what do we got? We got 8 times 10, so we'll make it 80. We'll make it a force of 80. Which is just, again, a problem inherent in, like, for instance, the source engine. Like, there aren't any units on these numbers. So we're doing some trial and error to figure out, oh, the basis for things. That's a little bit closer. So 80 is a little bit closer. 80 is too high, so I'm going to say that it's probably not 10 units. I'm going to say it's probably 9.8, and so we're going to do 9.8 times 8, which is, let's find out. 9.8 times 8, I actually did 9.81. 7.85, just about. Or, sorry, 75. 78.5. There we go. 78.5. I don't think that is going to achieve hover yet. I have a feeling that 78.5 is still too high. But we'll see. Nope. Let's see. What else can we, what other values can we try? Let's try, let's just dial it down to 64 and see if that does anything for us. All right, getting closer. I'm also going to set the thruster to toggle. That way I can pick it up and move it around and still have the thrust being applied and see what happens. So I'm going to say that maybe... Let's see. Half of 78.5 is not a bad idea, so I'm just gonna try. I'm gonna try 36. I'm gonna try 36 and see what that does for us. I think it's gonna be too low, and we'll see what happens if that's the case. Oh, ooh, very close. Actually, it's still too high. So 32. All right, thrusting, letting it go. Oh, and it's drifting up ever so gently. So what does this mean? Oh, there it goes. Let's see if we can find a more exact value. I'm gonna try 30. And so assuming that, hold on a second. Oh, no. 30 is exactly it. Okay, so there's something else happening here. You'll notice that the box isn't slowly drifting over time, despite being unfrozen. There's a minimum... Okay, so now it's slowly drifting because we nudged it in the opposite direction, but there's a minimum amount of motion for an object. There's a threshold of motion below which the game freezes the object and takes it out of the physics, calculations, etc., so that the game isn't trying to do kinematics on a bunch of objects that are sitting still. So I'm gonna change the sound to not be audible. None. So that way I can talk over it and be good. But I'll leave that on so that we can still see it. So it's a little bit less than 30, I think. So gravity on the object is a little bit less than, or a little bit more than, a little bit less than, hold on a second. Yeah, okay, so gravity on the object is a little bit less than 30 in the opposite direction, divided by its mass, which is 8, so 30 divided by 8 is going to be like, what, 7.5 divided by 2 is 33, so, yeah, 3.75, which is like a strange value. Why, like, okay, maybe it's, what else is 3? It's really strange. Let me make sure that the weight is right. It's possible that the weight is actually weight instead of mass, and that it's something else. Hold on, I need to write this down. Okay, I don't know what's going on yet. I gotta think about this for a second, but let me see if I can, in the meantime, get an even closer value. I'm gonna say like 29, 29 and a half, 29 and a half even. See what that does for us. 29. Oh, the object descends. Oh, but that could just be because it was a little bit off, and we're gonna talk about the orientation of the object later, because I'm gonna put thrusters on all the sides so that we can turn the object and it won't drift. So let's see. Yeah, we're still getting descent. So 29 is too low, and 30 is too high. 29.75. I don't know if the thruster is actually making this an integer value, or if it's just that the label here is rounding it for us. But it appears to be the case that the thruster is using engines, because I can't, or is rounding, because I can't see a significant difference between that and, let's see what happens if I just set it to 29. No, yeah, that is different. Okay, so let's see. 29.9. Oh, that's really close. 29.9 is really close. So I'm gonna move over to the other side where I have when I upload this video I'm gonna, I don't know how I'm gonna do this exactly. I didn't really think it through before I started streaming. But I'll have a B-roll where I have a camera pointed at some paper while I'm doing calculations to figure out what's going on. And so I'm gonna move over to that side now for a bit, for a moment. So we're gonna say the box has a thruster on the bottom whose mass equal to 1, and the cube itself has or weight. Let's say weight, because I feel like there's something going on here. And the weight of the cube is 8. Okay, sounds good. Going to work. So let's see, we got a weight of 8. Let's see. Okay, got a weight of 8. Assuming I'm not a complete idiot, weight is the force, mass times the acceleration of gravity. So 8 equals the true mass of the cube times the acceleration of gravity. I'm trying to figure out what the hell the acceleration of gravity is in this engine, in terms of the game units, because nothing has units on it, and I thought at first that the game engine used imperial units, and I'm beginning to wonder if that's not the case anymore. So let's see what else we got. It might take me a moment to think through this. What else we got? We got the sum of the masses times gravity in this direction, and then we got, from here, we got the thruster applying the thrust, and I'll call that, oh my god, I'm just gonna call it T. Our thrust equals 29.9 units, and also same thing is going on here. We got an approximate weight. What the hell is going on? Oh my god. Okay, so let's see. The thrust is about equal to the force of gravity on the object, which, yeah, is something like 29.9. So that is equal to the sum of the masses times gravitational acceleration, which I should just actually be, okay, I'm gonna make that consistent here, or alpha. Okay, I'm just gonna leave this here, and I'm gonna let anybody else who wants to look at that think about it, because I recognize that we can't see that work on the stream, so I'm gonna spend less time with it. So force is about 29.9, and that is really all we need, because with wires, oh, that's cool, right? Oh, look at that, it almost stabilized. So we got our cube, we got a force of 29.9 pointing up against gravity, and that's about what it is. So wire, we can program a wire thruster instead, having found that value, to be, oh, damn it. That's okay, we'll just do it again. Wire thruster with the same thrust value, 29.9. And the same model, which is real important. And what we should see is that, what? Oh, it doesn't like us using, that's, oh boy, okay, well, we'll see what happens. So model has a multiplier, y, oh, 3.61, kind of close to 3.75. I bet 3.61, what's 29.9? Still a little bit lower, but that could account for something, I don't know. Okay, all right, but here, this is the thing. If we know the total force of gravity on this object, we can split it into multiple components, such that each thruster creates a sum force versus gravity, no matter the orientation of the object, and we can do that with some trig and stuff. Yeah. So let's see. Let's just make sure that this works. We're gonna use our wire tool, which, if I recall correctly, has the ability to program in a constant value, or maybe that's a separate tool. Input, output, constant value. Yeah, I think that's gonna be, wow. Do we don't have that option anymore? All right, like that. I'm going to use a wire width of 0 so that hopefully, so that we're just not distracted by these things being connected to each other. I didn't give that a value. Constant value, we're going to make it not a, no, we're going to make that a number, and that number is going to be 29.9, and whether or not, I don't think it has to be 29.9, I think it has to be 1 or 0, but we'll see what happens. Because I think what happens is that the thruster has this multiplier, and it takes the number that gets fed into it and multiplies it by that. So I'm gonna make it 1 instead. So we're gonna redo this whole thing with the thruster. We're gonna make it a multiplier of 1, and then our constant value is gonna be 29.9, so that we can feed it into the. That's brilliant. Okay, hold on. So that we can feed it into the thruster. We can feed it into the thruster. What? And it'll multiply it by 1, and that should, if everything is working as expected, be our thrust value. So let's see what happens. Okay, correct. We did it. We got it. It's sending the thing a 29.9, and it's giving us that thrust. So we've seen this a few times already, but let's think about it a little bit more. So if I tilt the cube this way, and it's frozen in space right now. I froze it with the physics gun. We now have that same force pointing in this direction instead of straight down, meaning that less of this thrust is counteracting gravity. So what we should see happen is that since there's no external force on either side of the object, we'll see that the thrust projects it to the left and it falls due to gravity. And that's the case, basically. So let's do that 1 or 2 more times. I'll just be a bit more careful about it. So I'm just gonna unfreeze it. Oh. And it drifts. And also it turns a little bit because our thrust isn't at the center of the cube, it's on the outside, so there's some stuff going on with there's some like torque happening there. Yeah. Not only is the thrust not at the center of the cube, it's also not at the center of the thruster. I believe that the particle effect that indicates the thrust originates at the same point as the thrust in the calculation, so it's not even in the center of the thruster. Which is cool. That makes sense. So what do we do to counteract this drifting and, you know, angle error? Well, we put thrusters on the sides of the cube, and they will act in compensation of tilt in the in the bottom thruster. They'll make up for the missing components of the downward thrust, and also counteract the thrust, for instance, in this case to the right. This thruster will balance this one out, and the cube will stay stationary. This, of course, doesn't account for when the thrust is, or when the tilt is any greater than 90 degrees. I could put a thruster on the top. In fact, I might as well. But I wasn't originally going to do that, just so that we don't see, so that we don't see what? Oh, so that we can just easily see which side is the top. But this is an interesting question, because originally I started off discussing the thrusters by saying that they each had a weight that would affect the total weight of the object. And since we balanced the thruster's force to account for itself and the cube, what we should see is that it has some additional weight coming from these extra thrusters that hasn't been compensated for. So what we'll see is that we let go of the cube and it falls. But I might have been wrong about that the whole time. Nope, but I was right. So each of these has a weight of 1. 1 mass unit times 1 gravity unit, I guess. I'm trying to think of a way, like on the ball, because I haven't thought about this much in advance. I'm trying to think of a way that we could figure out what the hell our gravity is, and whether or not the weight is actually weight or if it's mass. But I'm pretty confident at this point that it's weight. So what are we going to do now? 29.9 is the magnitude of our thrust, and we could start out by thinking how we can change the direction of thrust without changing the magnitude. Or rather, you gotta think about how to split it into multiple components, which is like really like easy. It's conceptually, it's really easy. It makes a lot of sense, but I'm gonna have to take a minute to work through in my head what's going on here. So we got so while I imagine that many people will have a more informed perspective on this than I do, and thus be like, oh my god, like, what the hell is this idiot doing? Like, this is obvious. Trying to work through it just with what I know, because I think then what I can do is I'll make a briefer and better, more concise video about the process, which will be a bit more like didactic and less full of thinking time. Oh, I've moved the video. Forgot to stop it recording. I'm gonna just start fooling around without talking too much, and we'll see what happens. So we have our baseline theta, which is like 0. This is our angle in 2 dimensions at least. So I'm gonna think in 2 dimensions for the time being. So I am gonna remove these extraneous thrusters, and I'm just gonna think about this one here for now. So what'll happen is, if we call rotation in this direction a positive theta, that should mean that, actually, you know what? For ease, let's make this positive theta. And so I'll work from this side instead. So positive theta, positive deflection. And we'll get, at this orientation, this thruster needs to be 0. It needs to not be moving in either direction. At this orientation, both of these thrusters should be about square root of 2. Actually, so what I am gonna do is I'm gonna take the constant. Oop. My keyboard momentarily stopped working. Okay, so I'm gonna take that constant 29 and I'm gonna multiply it times the cosine of the orientation and then feed that to the bottom one and the sine of the orientation and feed it to this one. So in order to figure out the orientation, I need to use some wire component, and I'm not sure which it's going to be yet. I'm not seeing anything about angles yet. Force or hoverball. We could make this a little bit easier by using vector thrusters, but I think that would be more complicated. Vehicle input output detection is probably what we want. Entity marker, gyroscope. The thing is that the gyroscope is going to have weight also, and as soon as we put it on there, our value for it's going to go up. It's going to go up is the thing. And this is in degrees instead of radians. Entity marker, how does that work? Let's see. Oh, okay, excellent. Okay, we did it. We got it. So let's see what kind of outputs we get from the entity marker. Visuals, we got screens, indicators. Let's go with screens. One of these, digital screen, I think just outputs a number. That's backwards. Okay, so what I should see is, yeah, I got picked. Oh no, that's wrong. There's a text screen. Now this is the one we want. This is the one we want. That'll do it. Ah, God. Okay, so make an object. I'm gonna stick the screen on it. I'm gonna take that. I'm gonna put it over here, and we're gonna call our value A. What I should see is that I can plug it into. Wow, that's real helpful. Okay, never mind. Let's see. It's an entity marker. So what we should be getting out of that, the kind of output is an entity. Right, not a number. So entity 1, probably. So we need some entity. We need a chip that can interface with the entity. Probably a gate. Yes, and get its angles. Wow, okay, we did it. So angles. So what I'm going to do is I'm going to wire this entity to entity 1, which we should see that I can rotate this and that value has changed. It has. Okay, good. Very good. So what I'm seeing right here is that we got an X, a Y, and a Z. These are Euler angles, as opposed to, well, like quaternions or whatever. There's only 3 members instead of 4. So I'm going to just figure out which direction is theta x or whatever. Oh, what is our deflection in the x direction? So that appears to be the last value. Actually, so I'm gonna rotate it so that that is actually x. What I'm seeing is that this direction is world z, and this direction is probably world x. Does that make sense? That's okay. We'll get there. we'll figure it out. And if I'm wrong, we'll find out that that's the case. So angles, what are we doing now? We're gonna monitor the angles, not the, oh, that's gonna be a whole other challenge. That's okay. We're gonna see where the hell, oh, outputs an angle, not a number. So I'm gonna get another gate that'll take my angles, and it'll turn it into numbers. Decompose, that's what we want. So we're gonna get our input from that will be our angle, our out angle, and then hopefully, oh yeah, okay, yaw, pitch, and roll. So pitch and roll are the two. I don't know if it's using local, like the entities. That's okay, we'll get there eventually. So pitch, we'll make that the first one, and roll. Yeah. Okay, that makes sense. And then roll will be our second one. So we got a slight roll. And this is in degrees, which I don't like very much, and our screen isn't rounding. Floor. Okay, I'm gonna redo the screen here. We're gonna call this our pitch. And we're gonna call this our roll. And then we're gonna floor the screen value. We did that. We're gonna be good. I don't see anything else we need to change there, so we're gonna just update that. Oh my goodness, beautiful. Okay, so I'm gonna make this a little bit easier to look at. So our pitch is 0. Now it's gonna go up significantly, and it should go down this way. Okay, that's great. That's great. So now I'm gonna take that angle, which is now decomposed, and I'm gonna turn it into, I'm gonna convert it from maybe it would be easy to, no. We need to turn it from degrees to radians. So what? Ratio of 360 to 2 pi, so we'll just divide 360, divide our measurement by 2 pi. That's not correct. The other way around. Multiply it by 2 pi and divide it by 360. Does that sound right? I think that sounds right. I think that sounds correct. Angle, arithmetic. We're gonna add some multiply or divide. Oh, okay, so this is an excellent opportunity to talk about the structure of the wire mod. So each of these chips, and this would actually be better if I had used a non-zero value for the wires. Each of these chips feeds information into the next. It's basically like if you took, if you were a programmer and you took functions and you put each of them, like how functions are like a black box, and you literally created the black box and stuck it in the game world. Like each of these are essentially a function. The first one gets the angle from the entity, and then this one takes that angle, which is like a three-dimensional vector, or a three-dimensional vector thing, and turns it into individual angles. And then this one is going to divide. We're going to need two divide gates. So I'm gonna just use a constant value, and I'm gonna be 2 pi divided by 360 is 1.7453. 1.745. Oh, 0.017453. Okay. My calculator is set up to use scientific notation right now. It's in scientific notation, so I read out values and then I realize that I'm off by a couple orders of magnitude. So let's see. We need a constant value, and our constant value chip that we used earlier, this guy over here, has a couple spaces, so I'm just gonna reuse him, and I'm gonna add more spaces to him. So we got 29.9, which is the thrust that we needed for the cube plus 1 thruster, and I think that it's gonna be higher now because we're adding thrusters, but I'm gonna leave it at 29.9 for now, and we'll adjust that later. Then we're gonna make this our factor, 2 pi over 360, which is 0.01. I wrote that down. Oh, I forgot to stop that video recording. That's okay. All right, so we've done that. Now I'm gonna take it and I'm gonna, bam, it's in there. We got it. So now I'm gonna use my wire tool again, and I'm gonna take the. Okay, now we're using non-zero values for wires, so you'll be able to see the flow. In fact, I'll do that one so it's even more obvious. So, what am I doing? Divide. I'm gonna make it the b value because it's a over b. So I'm gonna take b and I'm gonna make it that factor. I'm gonna take b, make it that factor, and then I'm gonna take my yaw, make it our a. Or I'm gonna make it okay. So pitch. And then this will be our roll. And then, so this will now be our pitch. And the bottom one will be roll in radians instead of whatever. So what should we see happen now? That just looks wrong. Did I do something wrong here? Oh, it should be multiplies, not divides. Okay, so I wonder if it'll just keep the. Yeah, okay, look at that. Ah, damn it. Okay, so what's going on here? We got why did roll go up like that? What's going on? Value. What? Oh, okay, we should not be flooring the value because we're gonna get decimals here. So I'm gonna look at that screen. I'm gonna take that screen and I'm gonna make it not flooring the value. I'm gonna take it, I'm gonna go, bam. Okay, so we got a very small number. And then, I'm gonna say that's probably like square root of 2 divided by 2. What the hell is going on at 1 point? Oh, okay. Maybe I need to take the pi out of that factor. I think this will be okay. I think this is gonna be fine. So let's just proceed. Yeah. No, that's gonna be fine. This is what we need. So let's see. We need a sine and a cosine. So that we can transform our stuff. And I'm gonna make the wire a width of 0 again so that we don't see it traveling to the cube. So we're gonna sine, and that's gonna be our side one, and our cosine is gonna be our bottom one. So let us see. We got gates, we got trig gates, we got a sine, and we got a cosine in there. So I'm gonna take the. We could have done degrees this whole time, but I just like radians better. I don't even like radians really, but I get them a little bit better now. Okay, so we got our I'm gonna make it so that sine comes after cosine. So we got our cosine and then our sine. All right. So now we got, we're gonna get the, oh, we only need one of these angles even. Okay, so we got pitch and roll, and this is our roll. This dimension is our roll dimension. So positive roll is this way, negative roll is towards the thruster. So what I'm gonna do is I'm gonna take off this thruster and I'm gonna put it on the other side, so we're working with positive values at first, because we're gonna have to do some, each of these thrusters is gonna have like some other stuff going on. It'll have different inputs, and some of them are gonna be, we're gonna have to negate them. So I'm just gonna go with the simplest case first and make sure that we can get that working. Thruster. All right, so we got a second thruster. We got our bottom thruster is going to be linked to our cosine, and our cosine is going to be the cosine of the roll angle, which is the bottom one. Roll. Okay. And then sine, and that'll be a sine of our roll. That's cool. So now what do we gotta do? We gotta multiply our thrust by these factors. Which means we're gonna need 2 more multiply gates. Arithmetic multiply. Just like visually coding what's going on here. Alright, now what we're going to do is we're going to take our, so I actually wired these thrusters wrong. They're going to be to the multiplies instead of to the thing. So, cosine goes into the multiply gate, and the other factor in the multiply gate is going to be our 29.9, which is going to actually be higher because we're adding thrusters. And then this one, same deal. Except that it's going to the sine and the cosine instead. So now what we're going to do, we're going to wire our thruster. Wire a thruster, side thruster. Which one is this? This is the sine. And then this one is going to be the cosine. Alright, very good. So right now, this one is probably not, like, both of these have an input value already, but the input is 0 on this one, so I think that's why it's not firing. And this one has an input value, which is 29.9. So that's great. So really, I think what we should see happen is that as we tilt this thing, the thruster on this side will turn on. So that's just going to be the first observation we'll make. And it does. Excellent. So now what do we got? We got a thrust of, a force of 76.41. Interesting. Model multiplier, 21.41. Okay, there's a problem here. There's not a problem here. It seemed for a second to be problematic because we got a 21.141 and a 21.141 on this side, and that sums to 42.28, and that's greater than 29.9. But both of these are pointing away from our, our center, the direction that we want to be pointing in, really. Most of these are pointing away from gravity, so they're not all counteracting gravity. So what I suspect is that if we divide that sum by square root of 2, we'll get 29 point something. Oh, and we get 29.9. So what then I will see is that I let go of this thing and it'll drift down a little bit because 29.9 isn't high enough for this configuration. But they compensate so well. So let's see if I can make this a visual thing. Like if I can make the thruster scale with the input. I don't think that I can though, which is unfortunate. Maybe some of them do different things, but that's really unfortunate. I'm actually just not sure. Maybe there's another way that we can visualize this, but so what I'm gonna see right now is that, yep, I do that again and it compensates. Oh, and then it tilts. And it's gonna tilt back and forth until it's stabilized. And why is that happening? Let's see if we can figure out why that's happening. It's pretty simple. There's more mass on this side than there is on this side, so the cube is gonna tilt, and then the other one, and then it's gonna, yeah, this is great. So it tilts, and then the thrust stabilizes, and then something else happens. It just like does this pendulum thing because the thrusters are compensating to stabilize, and then once it passes like the equilibrium point or whatever, this side has more mass than this side, so it's going to swing back and forth until either it stabilizes or it like flips over completely because the thrusters are still working. So another thing that happens is that when this passes the equilibrium point, and this is good because it demonstrates the thrusters kind of flipping over, is that they do exactly that. Their direction of thrust flips. They can have a negative value. So this guy is now thrusting on this side, and this one is thrusting on this side. So there's a force going this way and a force going this way, but the weight is still off. The balance is still off, so it's still going to swing a little bit. And it does. And then it flips, and then it stabilizes, and then it's going to try to stay upright. But here's something that we haven't considered yet, is what happens if we just take the cube and we turn it this way? Does that still... I think that it will still compensate, because it's using pitch and roll, which are relative measures for the cube's orientation. So like the direction that roll and pitch are in proportion to the world changes as the cube changes its position. So if we, yeah, no matter which direction this cube is facing, it'll still do the thing. But we haven't added another thruster on this side to compensate for this. So, oh boy. All right, so that's great. So there's some problems here that we haven't compensated for yet. So we need to add at least one more thruster, and then what we'll end up getting is a cube that balances on its corner. I'm just going to take a second to copy my live link, and I'm going to send it to a friend of mine. And I'm going to... Oh shit. Okay. All right, and then we're gonna get back to this. So, oops. All right. So cube that balances on its corner. We're gonna make another one of these multiplication like chains, and it's gonna go from the. Actually, no, we already have this. We haven't used the pitch we've used the pitch but not the roll, or we've used the roll but not the pitch? We've used the roll but not the pitch. So pitch is going to be positive in which direction? It's going to be negative in this direction, so it's going to be positive this way. So when we have positive pitch, we need this thruster to fire. So I'm going to put the thruster over here. All right. And now we're going to wire it up to, oh, we're going to need to do one more multiplication bit. Gate, sine, it's going to be, what's going to be sine because it's on the side. So we need a trig, and then we're going to multiply it, sine, rad. Oh, I'm going to make this a big ol' sub-circle thing. Bang, bang, boom. Alright, and then we're going to need a multiply. And we're going to do exactly the same thing that we did for the other ones. In that we are going to, let's see, we're going to take our pitch angle, which is 0.75, so it's going to be the top one, or 785. And then we're going to take that value, and we're going to multiply it by our constant, which is, as we add thrusters, becoming ever less accurate. Okay. All right. So now we got thrusters all firing in conjunction as the thing changes its orientation, but something's going on here. This one's not turning on, and I don't know why. Did I? Oh, I might have. I wired it up wrong. So this is a problem. So this one. Okay, let's get us back to our baseline, because I think I wired up one of them with the wrong direction. This is correct. What the hell is going on? I'm gonna unwire this input. This one is not wired in the first place. Okay, so let's find our pitch again. Our pitch is this way, so this is gonna be the last one that we did. Gonna go to our pitch. This one is going to our roll, right? It's the other sine one, yeah. A roll, which is very tiny right now, so it's close to 0, so the thruster isn't firing. And when we do it like this, voila, we got a cube that's trying to balance on its corner. Somehow, okay, so last thing that we're gonna do is we're gonna make these thrusters not bidirectional, so that we can put thrusters on the opposite side of the cube and see what happens. So bidirectional, uncheck. All right, 1, 2, 3. And so what we'll see is that when negative values are put into the thruster, either they'll continue to fire, which would be bad, or they will be detected as like below 0, and they'll just go below 0 and not fire. Okay, that's good. That's exactly what we want. These thrusters are not firing when they're pointing down. So now we gotta, oh man, this is like really getting positive. So, well, it doesn't really matter because, but notice how roll is now the value of pi instead of 0. That's okay though. That's okay, because that's supposed to happen. Oh, so it means that it's below 0. It means that our angle is like a little bit negative, a tiny bit negative. So, oh boy. All right. So what we need now is for each of these, we need a second output that's going to be the negated version of them, which is really simple. We just take a gate and we do, it should be arithmetic. I'm looking for a sign. There we go. Negative. Nope, that's not right. Subtract. Negate. There we are. So for each of these, they're going to have a, I'm going to make that a different shape. Oh my god. None of these are satisfactory. Okay, that looks like a negative sign. That'll do. Negate. Okay, and so, an important part about, like point about WireMod is that, although we've like wired one input to the next, you can take output to more than one input at a time. So what we can do is we've taken this multiplied value and thrown it to this bottom thruster, but we can also send it to the negate chip without taking it away from the thruster. So now we've got a negative version of the value. So we're going to put a thruster on the top, and we're going to wire that up to be, we're going to wire that up to the negative version. We're going to do the same thing for each of these. And now I'm going to have a moment where I struggle to remember which direction is which. Oh, my keyboard input is lacking. Okay. Pitch is this direction. So our pitch, so it's, 0.7, that's our pitch, I'm going to take this negative, bam, I'm going to make another thruster on the opposite side. Where are thrusters? There we go. And this will be attached to our negative pitch, which is scaled according to our thrust value. And then finally, we're going to make one last thruster, which will be our negative roll. And we're going to stick it right there, and we're going to wire it up to the negative, which may not be wired itself, it's not. Alright, and so what we should see is that no matter what orientation this thing is in, at least one thruster is going to be going, and at max 3 is going to be going. Ooh, it's like really struggling. Okay, so what I'm seeing is that no, that's about right. There's some slight offness. Something's off here. That guy shouldn't be going. I don't know why he's going. Oh, and he's not going when it's vertical. What's going on? Alright, I'm gonna have to find our original 0 point. This is our 0 point. Very good. Let's see if we can diagnose this issue. Got a positive pitch. Oh, 29.9. This is wrong. This is too high. Because this should be 21.14, and this is our original. Oh, he should be going to the cosine, and one of these is going to go to the negative cosine, which I'm not sure if I did. Multiply by 29.9. Multiply by negative 29.9. I may have wired them up backwards just now. I don't think that I did. looks a little bit better. Still not totally right. Because this cube is not, as I suggested earlier, balancing on its corner perfectly. Okay, this is a problem. Which one is this? I got one of these wired up to their negative. This one has a value of 0. This one also has a value of 0. See if we can get them to be positive. Oh, that's weird. Okay, so these both shouldn't be firing at the same time. This is... What do we have that's a 29.9 right now? Positive 29? Two of these are 29. Something's fishy. Yeah, one of these is doing like the wrong thing. I don't know which one it is. Okay, but it's not the worst thing I've ever seen. That's kind of cool. My goal is to get this to stabilize. I want to say that if we take that thrust value and like reduce it markedly, we'll get a more stable thing going on here. So let's see, where's my constant value? We're gonna make it like 20. 20. Right, and we're gonna stick there. So that should reduce dramatically our obnoxious behavior. Oh, but there's still something going on. What I'm noticing is that one of these pairs of thrusters is going up. Yeah, that's it. That's it. So we're at roll F5. 0, pitch of F pi. Which one is pitch now? Oh, okay, so pitch is half pi, so one of these should be firing at half strength. It's going to be this one. It's not. That one's at full strength, so... I'm not sure how to deduce which one is not supposed to be firing, so I'm just going to take... I'm going to look for... Oh. These might all three be linked to the same one incorrectly. 20, 0, 20. Why does that happen? This is a pitch. This is a roll. Pitch. We go in here. Oh, let's see what happens. 45 degrees. That's... Okay. That is less than 20. That is about 20. Actually, no. There are two problems here. This one is at 20. It shouldn't be. It should be at 0. So this one should be... Why is this happening to me? This is like a whole mess. Okay, we're gonna redo the thrusters from scratch now that we've got our input set up. I think that I may have made a mistake somewhere in the wiring, but also I'm just not sure that that's the case. So we're gonna find our 0 point again. All right, 0, 0. Positive pitch, negative pitch. I'm gonna turn this around again. So we're gonna do our positives first. Positive pitch on the opposing side, and I'm thinking positive roll is gonna be on this side. Yeah. Okay. So this side will be roll, this side will be pitch. Positive. Our positive pitch, which is, leave that one as the last one. One should be our positive roll, except that we're getting a negative. Are we getting a negative value for roll? Let's see, our positive. Oh, negative roll. This is negative roll. All right, that was. All right. Positive pitch. Let's go. Oh, we already did that, so we'll tilt it this way and it'll turn on. Very good. Now positive roll. Roll. All right. I'll be the middle one, I believe. Right, very good. So we'll turn it this way and it'll turn on. Very good. All right. So we set it up like this initially. So let's do negative yaw. This will be our negative yaw, which is our cosine, which is the first value over there. It's negative. Right. Good. And this one is our pitch, right? Right. So we're gonna take on negative pitch. Make our shit, which one is pitch? I believe it's that one. Right. Yeah, roll, pitch. Yeah, because I did the pitch last. So we'll tilt it this way and see it turn on. Very good. Alright, and one last thing. We need the negative roll, which is this one, which is our last thruster. I kind of suspect that we're gonna get some, like, the same issue as before, but we'll see if that turns out to be the case. Okay, so this is exactly what I was looking for. A maximum at a given time of 3 on, and a minimum of 1. It still spins kind of out of control, but let's see what happens if I adjust our strength value again, and I'm gonna make it like 30 flat. Oh, what the hell? There we go. All right, 30. That's not supposed to be happening. Something is wrong. Like, why is the thing propelling itself in this direction. Oh, also, let's just make sure that that thing update, the value updated. We got like some zeros. We got a 29.9. That's what we were looking for. That's still too low. I'm gonna make it 30. All right, so we've got, my goodness. So a little bit less than 30 was what we had before. Each of these should have like a weight or mass of 1. I'm not sure which yet. So I'm gonna say that the accurate value should have been 35. Say it should be 35. A little bit less than 35. So we'll see it drift upwards. No, not even. What is going on? I hesitated for a moment because I know that sometimes with WireMod, in order to update values, you have to rewire things completely. Oh. Okay, so we didn't add anything to compensate for rotation, but we noticed that in general the box is hovering, even though it's spinning around out of control. It's pretty much hovering. It's not exactly stationary. And something is causing it to like tilt. I don't know what it is. Like something must just be a little bit off center. I think that if we had, if we had a larger object and instead of having the thrusters in the middle, we had them on like the corners, we'd have a much more stable. We have a much more stable thing going on. I don't know if I can call this a success yet. I mean, it's pretty cool. And interestingly, I had to raise the what's this at? This is at a value of 40, which it should not be. These are also at values of 40. Maybe there's like some gimbal lock or something going on. We got drift. This is just brilliant. This is like really cool to watch though. I don't know what else to say about this at this point. I think if the rotation was a bit more stable, I'd be comfortable saying that this was the solution. But that we did it, you know? I just feel like it needs a little bit of something. Okay, so that's cool. We got one object working. We got one pretty cool object, and so I'll just summarize what's happening here. We have a cube which detects its orientation and then fires individual thrusters in order to maintain a relatively stable position in 3 dimensions, especially against the effects of gravity and yeah. Let's see if it doesn't. Okay, so it doesn't respond to its actual acceleration. It responds to the theoretical, like the acceleration that comes from gravity, but it doesn't like detect its change in velocity from one frame to the next, which could be another thing to work on. An important piece of information about this experiment is that we used lots of discrete parts, which earlier I referenced being like programming and taking functions and, you know, taking the black boxes that represent functions and making them actual boxes in the game world. Next, what I think I'd like to use is a chip called Expression2, which allows us, what does it allow us to do? It literally allows us to program in the game. Like, we can go in here and we can right click and we get this code. We can code in the game. So then we can use that to pump data into the, you know, into these various chips and into the thrusters in a much more compact way. So we could do all of this again in Expression2, which I'm considering doing, but right now I don't have the, in front of me, I don't have the reference for Expression2 to figure out how to do trigonometry, for instance, but that should be easy enough to do. And I've got the Steam overlay, so let's see what we can do with that. Expression2. From what I can tell, which is kind of cool, the I don't know what's electric cutting machine. Expression2. Okay. Anyway, there's probably not like a great reference for this. It might be all right. Let's see. We got a timer. We got unit conversions. We got signals, holograms, bitwise. Oh, holograms are really cool. And I might try and use one of those in a bit. Self-aware, debug, timer, table, angle, matrix. What am I looking for? Trigonometry. Callable advanced extensions. I'm looking for functions, really. Function, do something. Ah, there we go. Okay, so do I have to prefix this with anything? Numbers. All right, we can just sine, cosine, tan, cotangent. Yeah. All right, so we're gonna just, what I'm gonna do is I'm gonna redo this in Expression2 instead of individual wire bits. I think that GMod is a great way to learn to think about programming, especially game programming, because it forces you to break down complicated problems into individual components that you solve for in like a logically sequential way, and then you can reinterpret your results as in like a programmatic algorithmic way, which is what I'm about to do. So in here we're going to get our inputs, which will be pitch, yaw, roll, which I don't know if I have to prefix these a certain way. How do variables work? Oh, that's nice of you. I don't know if I closed this before or if I just... Variables, there we go. Will not work. All variables start with a capital letter. Okay, so maybe that's all I did wrong. So, okay. P. Oh, there we go. Okay. This is... You're not supposed to do that. You're not supposed to just use a capital letter for something, but I'm going to do that because I don't give a fuck. So let's see. I'm going to just take a quick look back at what we have. Oh, invalid characters. Oh, I guess you're not supposed to use commas. E-Y-R. There we go. Excellent. Okay, so we start with this constant, these two constants over here, which are the conversion from degrees to radians, and the thrust constant, or the our thrust constant, which is the total magnitude of force that we need to overcome in order to be at a stable position in space. Stable being a relative expression. I hope that you can see that despite this spiraling out of control behavior, it's still hovering in about one place, which is the goal for now. What I'd like to do is, in a third iteration, I'm going to take away the thruster component, and I'm just going to use expression 2's apply force function, which moves around objects by applying a force to their center of mass instead of to the outer edges, defined by models and like some other mass that we don't really know how to account for yet. So I'm gonna take this, I'm gonna take it over there. So where were they going? We got these constants, we got the entity's angle decomposed into components, which I think is where I'm gonna start. I'm gonna start with the decomposed angles and wire them to the inputs here. I need my wire tool. I'm gonna make that my pitch. I'm gonna make yaw my yaw. Make R my roll. Good. Alright, now, we're gonna go back into expression 2. I'm gonna right click on this guy. Left click. Create expression 2, open express. Yeah, there we go. Okay. Outputs. Oh, this is gonna be fun. Okay, so top, bottom, left, right, front, back. You know what? Okay. No. Yeah, I just would prefer to keep these single letters. And hopefully nothing is unwired here. Very good, that's all good. So let's go back. Expression 2. So persist, name, trigger, blah blah blah. Top. Oh, honestly, this is excellent. We're already. We're gonna find that this is much shorter to do. So we have. We have a total of 6 expressions. One of them is going to be the positive and negative versions of the cosine of our pitch. Positive and negative versions of the cosine of something. Where's our cosine? Figure this out. Negative 45 degrees. Roll negative 90. This is happening again. This is strange. This isn't supposed to be happening. I wonder if it changes when I... Okay, I guess it's just like a minuscule error. Pitch roll? Are we 0 yet? 0. Have found 0. So this is either going to be the positive or the negative. So we'll see that the cosine is positive. Okay, this is our original orientation. So, what is this? This is the oh my god. Okay, so cosine of something. Maybe it should be the cosine of, like, multiple things? We'll figure that out later. So the cosine of... Let's see. I don't remember what I linked it to. This is why it would be a good idea to use the wires. Well, let's see. Let's see if I make the pitch. Okay, I made the roll positive a little bit, and we'll see if that went positive. It is positive. Oh, these are both positive. A real issue. Fumbling around. I don't know what I'm doing. Okay, we're gonna think about this again, and we're gonna say that our bottom thrust is going to be equal to the cosine of one of our angles, and I don't know if it matters which. But I think actually that might be one of the reasons that this thing is like behaving strangely, is that it's responding to changes in one either pitch or roll, but not the other, which makes a lot of sense. So I'm going to call it cosine of pitch, and then we're going to multiply that by, it's going to be positive, and it's going to be degrees to radians, and then we got our thrust equals 40.00. Oh, I don't know if we have to, that's weird. Is there's something I'm missing there? Degrees to rad 0.01, 7453, 7453. So bottom is gonna be thrust. Oh, okay, P times degrees to radians. Oh, but we gotta look at this reference again real quick and make sure that sine takes an input, or sine and cosine both take an input in radians, not degrees. Returns the sine of n degrees. Really, that is okay, because you know what? That just means that we don't have to use the degrees to radians thing. Okay, so we got p in degrees. That times thrust. Our top is going to be the same thing, but negative. Thrust times -1. And I like to put things in parentheses. All right. Another step. Top bottom left is going to be sine of, oh boy, this is, what is left, really? What does it mean to be left? Top, bottom, left, right, front, back. Maybe this should be, I'm gonna say top and bottom still, and left I'm gonna say P positive, P negative. So pitch positive, pitch negative, and then roll positive, roll negative. That's better. Bottom and top are going to be the same. Left is... Something about that is just really bothering me. I don't know what it is yet. We'll figure it out. Alright, so we're going to say pitch positive is going to be the sine of pitch times thrust, and that's really, that makes things a lot easier to think about now. So pitch negative is going to be sine of P times thrust times -1. Then we're going to make our roll positive equal to the sine of our roll times, ooh, gonna be sine of... So I'm making an assumption here, I recognize, that this code runs like every frame or runs in a repeated way over time. And I believe that that's the case. I'm gonna, real quick, I'm gonna save it as our, Q thrust component, whatever, components. Okay, it's saved, and now we're gonna refresh it, upload it. Oh man! Oh my god, it got rid of it! It didn't. Okay, so I did this wrong. This should be a sign. There we go, that's a lot better. That makes me happy. Alright, there we go. Okay, so we got all of this. So we got the convention that I've been using is that the side P positive is the thruster that responds to positive changes in pitch. So we're gonna find our baseline, we're gonna find our, this is our baseline still, right? No, we're off by 90 degrees. Almost. Somehow, I've missed something. Pitch is about, this should be like, should be about right. Right? If I flip this over, what do we get? Almost 0. Okay, 0, 0, 0, 0, 0, 0, 0. I wish I could like highlight which things this is wired to. What is this wired to? Oh, namer! Look at that! We can name components. Okay, that's good. So we're gonna establish our convention here. We're gonna say bottom. I'm gonna make this top. Really, I suspect that either of these is gonna be appropriate. Either of these is gonna be fine as long as we get the our roll is negative. So I'm gonna roll in positive is gonna be this side. Roll negative is gonna be over here. But this really brings up a question, like, why, and I haven't really had a lot of time to stop and think about this, but why is it that we approached the top and bottom thrusters so differently from the sides? Like, something is not being compensated for here yet, and I just have yet to figure out what it is. So let's see, we got our positive roll, negative roll, positive roll, correct. Alright, very good. Now we should have, I'm gonna make the guess that this one is our positive pitch. I was wrong, so this is P-neg. Gonna be P-pos. Alright, and so this is great because now we just know exactly where to wire everything. And what we should see is that as we wire, if I've done everything correctly, we won't have any, like, nothing will change. The thruster will continue firing exactly as it is now. Alright, so let's see, we got bottom, to bottom. We're gonna have top, to top. We're gonna have R positive to R positive. We're gonna have R negative. Oh, I didn't really even look at that one. That's right, right? R negative, right? P positive to P positive. And P negative, right? To P negative. And we see that this is essentially the case. Now that the wiring is going to E2 instead. Oh, something is different though. Something is clearly different. Maybe not that different, but like, something doesn't seem right here, you know? Let's... that was dramatic. Yeah, why is that happening? Hold on. So this is firing at full strength. It should not be. This is firing at what is probably the correct strength. So it's gonna push up that way. Yeah. Okay, that's a little bit better. Why would it do that? Which one is this? This one is bottom. Okay, so the bottom and the top are categorically giving us problems because they are... You know what I'm gonna do? I'm gonna see if this does anything for us. I'm gonna go into the expression too, and I'm gonna tweak the behavior. You can see how this is a bit easier now because what I'm doing, what I'm gonna do is I'm gonna make this half cosine P and half cosine of roll, and I'm gonna sum them together and see what that gives me. In fact, I also realize now that I can set these equal to expressions in terms of each other, and I'm going to do that momentarily. So first I'm just going to look at this one. P times cosine P times thrust divided by 2, 0, plus, and I don't know why I think this is going to work correctly. Something tells me that it might not. Cosine of roll times thrust 2.0. Alright, then I'm going to set top equal to bottom negative. So that's a lot less code to write. So let's see, cosine P times thrust divided by 2, cosine roll times thrust divided by 2. And this makes sense because what I recognize now is that the top and bottom were responding to changes in pitch, but not roll. But roll is still an important component of the thing, so there were times when it was firing incorrectly related to something else. Okay, so sine of pitch times thrust, R negative, R pause. Oh, P pause, P pause. Could have been bad. Alright, let's see what happens. Alright, success. Now, that's a little bit better, but it's still not right. 34.4, because these two should be equivalent, and they are not. Well, let's see if it behaves any better. Not especially. Really not especially. So the question here now is how do we... This is at 40. It shouldn't be at 40. This one is at 28 point. It shouldn't be. One is at 14, which shouldn't be on at all. There's something up here. This one is bottom. This one is R negative. This one is P negative. Maybe it depends on like which direction it's approaching from. See that? Looks a little bit better. Oh, that does not. So what's happening there? These two thrusters are too high. 14, this is at 40. This one shouldn't be on at all. This is bottom again. So let's see if I can isolate some more scenarios where there are thrusters on that just shouldn't be at all. Yeah, this one again, top or bottom? Bottom. Okay, so I really need to not have done what I did there. Assign P times thrust. Alright. Load and exit. And that was pretty simple. We fixed that error. Oh my god. Maybe... do all of these. Let's see if we can diagnose what's happening here. This bottom is gimbal lock. I think gimbal lock is the thing going on here. But maybe that's just, I'm really excited to use that expression. So if we got our angle right now should be negative roll, that's correct, and no pitch. So this should be 0 roll and 0 pitch, which is right. Bottom is good. Bottom is fine. And as we tilt this way, we should have, just a little bit, we should have R negative, R negative should be less than this, which is still really close to 40. 40. Oh. Not divided by 2, but okay, let's see what happens if I do this. Cosine of P times, so what did I say? Oh, is that right? No. Oh. Let's see how exponentiation works. EXP. Oh, we can do that. We can do, oh, cool. I'm glad that E2 features that. This is gonna be really funny. Sine of P times first. So I'm just using my intuition right now to say that we need something here has to be set to 1, which 1 times thrust squared to 2 times. That looks right to me. So we're gonna try this. I don't know if it does, if you can do less than 1. Let's see. Oh, it worked. Okay. So this should be more accurate. It doesn't appear to be, especially. Oh, that's okay. I don't know what I expected. It's going to be on all the time because it's set to 1 times the thrust, essentially. Although so that was the wrong property that I just used there. I'm so close. I don't know. I don't know what I'm doing wrong. Somehow we have to account for both P. Oh, wait. What the hell? Cosine P and cosine R are what we want here. So this might be the answer anyway. I don't. Oh, that's greater than. That's wrong. That is flat out wrong. Okay. Oh yeah, because it still has to be able to be negative, so it can't be squared and it can't be under a square root. So, but did I maybe type that wrong before too? Oh my god, did I do it? Not quite. Because that guy is still maybe. Okay, I'm gonna take a break from this problem for a moment. You trying to come inside? I know, come on. we know this vector, how do you present the others? Right now, I'm trying to think about this. That we have. We have to see if we can get back into this. I still don't know the answer. I haven't looked it up. Perhaps because I'm not totally sure what the question is that I'm trying to answer yet. And I think, wait, I know what it is, but I don't know how to conceptualize it, so we'll get there. Got some oatmeal. I'm feeling ready to return. Alright. I'm going to re-summarize quickly where we are, where we have been. Here in Gary's mod we have this cube here, to which we've affixed 6 thrusters, who are meant to preserve its vertical position, that is, counteract the forces of gravitational acceleration within the game. This was a simple problem to solve with one thruster already pointed in the direction of gravity. However, I think we've done it again. Alright, very good. Just like this. However, because just like real life, but for different reasons, the game engine isn't totally precise. There's naturally going to be some drift. Some directional drift. Like that. So how do we get the other thrusters to compensate for changes in the angle of the thing vertically, so that it provides a constant upward force, so that each thruster does its part, and only its part, to keep the thing floating vertically. Clearly I've made a mistake in here somewhere. I'm trying to figure out where it is. What I'm noticing is that at a given time, there should be a minimum of 1 and a maximum of 3 thrusters firing at a given time, so that no thrusters counteract each other, and no thruster pushes to the side. However, occasionally, I've been getting either the wrong thrusters firing, or they're firing in the wrong magnitudes. For instance, these bottom 2 should be equivalent. However, this one is 40, which is the max, and this one is 28, which is correct. We're trying to negate a downward force of about 40, whatever these thrust units are, so that each of these does what? What do they do? They sum to the total force vector down. So I'm gonna probably try and work through this again without talking too much about it, because I think the thinking process will be pretty internal, so let's see if I can just focus on that. That's right. That's not right, actually. They're equivalent. Oh. Should not be 0, that should be 40. Move this up. Bottom down. I think I've assigned the wrong ones to be top and bottom. That's firing at 40 and that is firing at 0. This one is firing at 4. Oh, it's just stuck. Huh.